Hello, everybody. Welcome back to Advent of Code. Before we get started with day 6, I think I just want to mention a couple things about day 5. So day 5, part 1, we constructed this like giant B tree map, right, of all of these points that we had to deal with. So we had a struct called points, which I guess is relevant to show as well. So we had the struct called point with an X and a Y, which were I16s. I think these had to be I16s. I didn't actually check, but reducing the space it took. So we started off with our initial implementation for part 1, taking like 2.3 megabytes, which I wasn't super happy with. And you'll see that I used I16s instead of I32s in point, which took us down 600K. And then using a U8 in the B tree map instead of, I think we had an I32 there, took us down like another 500K. Yeah, I mean, we're doing a kind of problem where we have to kind of allocate this whole B tree map before we do anything else. I don't think there was any way to like fold over the input as it came in and then deal with it that way, because the B tree map was kind of like marking the number of intersecting lines, I guess. So keeping track of the number of points. So yeah, I don't think there's really any way to like fold over this somehow and reduce the runtime memory. But we did get the actual total usage down a whole meg in part 1. And then part 2 went up to almost 4 meg, and I brought it down to 2. So we cut it in half with basically the same approach. So the lesson here is like, if you're going to be allocating a lot of integers, choose the size of your integers well, because that reflects how they're stored in memory, and it reflects how much memory you're actually going to use. So if you know you're not going to use some obscenely large number, you don't need to use a U64. Day 5 to day 6. I guess we're in day 6 now, right? Let's do our typical get rid of everything up here. Lanternfish. All right. Seafloor is getting steeper. Maybe the slay keys got carried this way. Okay, sure. Trying to scan to actually find the relevant information is one of the critical skills of Advent of Code. You can model each fish as a single number that represents the number of days until it creates a new lanternfish. Okay. New lanternfish get 2 additional days. So suppose you have a lanternfish with an internal timer value of 3. After 1 day, it goes 2, then 1, then 0. Then it resets to 6, and it would create a new lanternfish with an internal timer of 8. So if we have a fish at 0, it creates a new fish and gets put into like the 6 bucket, we'll call it. After another day, the first lanternfish would have an internal timer of 5, and the second would have an internal timer of 7. Okay. The new lanternfish. Okay, a lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is included as a valid timer value. The new lanternfish starts with an internal timer of 8 and does not start counting down until the next day. Isn't this true for both of them? This is worded super oddly. Like, I'm not sure why they're saying this and then specifying that this one doesn't start until the next day. Because like, we're at 0, then we create a bunch of 6s, like fish with lifetime 6, and we create an additional number of fish with lifetime 8, and those both count down the next day, right? Like, it's not like we go from 0 to 6 and then we spawn the new fish and we go to 5, but 8 stays the same, right? Realizing what you're trying to do, the submarine automatically produces a list of the ages of several hundred nearby lanternfish. For example, suppose you were given 3, 4, 3, 1, 2. That's going to be our test input. Okay, so we've got 3, 4, 3, 1, 2. List would mean that the first fish has 3, then 4, then 3, then 1, then 2. So they all go down, and when they go down to 0, the next step kicks them back up to 6 and adds an additional fish on the end. Got it. And that grows forever. Okay, here we go. Each day, a 0 becomes a 6 and adds a new 8 to the end of the list, while each other number decreases by 1. Okay, y'all could do a better job of explaining this. The input, luckily, is clear in what happens. In this example, after 18 days, there are a total of 26 fish. So let's do process input for days, and then the answer is 26. After 80 days, there would be a total of 5934. So we actually have 2 tests we can build here. 80, 5934. Okay. Find a way to simulate lanternfish. How many lanternfish would there be after 80 days? So a couple of thoughts here. First one is that we can code it or we can encode it exactly as they do right here, and that would be fine. Basically, we would take a vec, we would parse into the vec, we would iterate over the vec, and then append to the end, which I think is actually, we could do that first, and then we could switch if we need to. The other approach is, well, two other approaches. One is in the simulation, we can stick this, or not this, but we can create basically, we have two things to track, right? We have a time that is decreasing by 1, and we have the number of fish in that group. So let's say we had, like, in this first example, we have 2 fish in group 3. So we could have like an array with 8 or 9 values. And the fish at position 3 would have the number 2. The array position 4 would have the number 1. Everything else would have either 1, 1, or 0. And then we could just rotate it around, which I think is the better option, but I think it wouldn't show us. I think the mutation for new people who are new to Rust is useful for the other approach. So I'm going to start with that. So we're going to start by returning a vec of U8s, and this is going to be digit 1, right? So we, I think that's the, yeah. So we have a bunch of numbers from 0 to 9 and separated by commas. So we end up with a vec of U8s, and we don't know how big this vec is going to be. So we have to do it like this. We have to allocate. That gives us fish, which we could make mutable, right? Which I think we will have to make mutable, but then we do something like, actually this takes a number of days, right? I'm going to make this very clear. Num days to process, and we'll make this like a U32 for whatever reason. We can process forever. For I in 0 to num days to process, we would have to downtick everything. So actually, let's do this instead. Let's do fish.iter, is iter mute is the thing, right? Let's call this fishes just to differentiate. Shadowing works just fine, but we're gonna do it like this. And then we're gonna do, there's gonna be some kind of loop here for day in 0 ... num days to process. That's what we're gonna do. We're gonna basically do a double loop here. And then for fish in fishes, iter mute, we will do match fish. And if it's 0, then fish equals 6, let new fish equal some vec that we're going to push into. Fish equals 6, new fish dot push 8. If we are at anything 1 through 8, then we set fish minus equal 1. And if we're at anything else, then we panic because that shouldn't be possible. So for each day that we have to process, then we create a new fish array to track all of the fish that we have, like, that are coming in, basically, because we don't want to be mutating fishes while we're iterating fishes, right? And then for each fish, we do the thing that we need to. If we have an immortal fish, we run. So I think we can do fishes dot extend from slice. I think extend from slice will work. Apparently Rust Analyzer doesn't want to work, so that's wonderful. A lot of Rust Analyzer problems on stream this month. Let's go look up the vec. Okay, so we can just copy stuff in. So extend. It has dot extend, apparently. There's extend. Extend is a trait? I didn't know that. We're learning new stuff every day. Extends a collection with the contents of an iterator. Okay, so that's with an iterator. We do have an iterator, but we also have a slice, and we don't need to iterate, I guess. This function is the same as extend, except that it is specialized to work with slices instead. If and when Rust gets specialization, this function will likely be deprecated. Okay, but still available. Copies elements from source range to the end of the iterator. Interesting. Okay, so I think we're going to do extend from slice. I think that works for us, at least. It allocates, it copies. We're not going to worry about that for now. We're just going to say bonk. Bin part 1. Can't find cargo toml because I'm not even in day 6. Expected U8 found stir. Did I return strings from this? I did. Let's just do this. Fish.iter.map s.parse. Wait, why is that a string? Oh wait, no, it's actually an error in here. Okay, cool. We're good. We're good. And then we collect, and then we have additional problems. We're going to unwrap because all of these have to work. If they don't work, then we are sunk. Exclusive range pattern syntax is experimental. I didn't know that. I thought that was just going to be a thing. Do we want to go experimental? I guess I can show how to do it without experimental. Ta-da! You can use a pipe. So we have a zero, we're matching on fish, which is a U8. And then if it's 0, we do something. If it's 1 or 2 or 3, etc., like all the way up to 8, then we do something else. And you can do this for anything as well. So inclusive ranges work, exclusive ranges don't. The difference between an inclusive range and an exclusive range is going to be like one of these equal signs on it, which means that we start at 1. And if we have an equal sign, then we include the last number in this case, which is 7, which actually needs to be 8, I think. And an exclusive range is if we don't have this equal sign, then it's just 1 to 7. We do have the equal sign, it's 1 to 8. This is going to be a mutability problem. Both of these are failing, which is fine because we're not actually returning anything. What is our, we don't need day here. What is our intended effect, actually, now that I total number of fish? So length of fishes. Okay. And that works for both of them. So this works. This is like, this is the way you might write it if you are unaware of different kinds of data structures and things like that, right? This is all fairly simple code. It's a couple of for loops. We're allocating all over the place. Let's run the answer, and then we will do a heap allocation, and maybe we do criterion on these, and then we move them to the VecDeque or deque or whatever it's called. I don't actually know what it's called. Where's our input? There's our input. Save, and then test input doesn't exist. And then how many days do we need to do here? 5, 9, 3, 4. Part 1, fishes, intermute. Wait, that's not right. 80 days. It is 80 days. Okay, so cargo run. Let's do the build with the release, actually. We'll build with release. We'll target release part 1. And we get like 2 megabytes worth of allocation here. So let me drop that into the README. I don't like calling things the naive approach. What do we call this? Double for loops and lots. We'll call it that. And then let's check to see. Oh, wait. No, I didn't actually enter the thing. It could potentially be the wrong problem or the wrong answer. It's not the wrong answer. We're good. Yay. Suppose the lanternfish live forever and have unlimited food and space. Would they take over the entire ocean? After 250 days in the example above, there would be a total of some massive amount of lanternfish. How many after 256? What are the chances this like just absolutely crashes? Like just straight up like, sorry, overflow. We're done here. 256. We're going to do this and we're going to wait. We could probably just keep that running and see if it finishes by the end of the stream. Do you know what the other problem is actually? The other problem is that dhat is slow. So like this isn't actually running optimized. This is running in a way that is like not necessarily. I thought my fans kicked up on my computer. I was going to laugh. So let's get rid of dhat in the build, and we just won't do dhat for dhat. Got him. And we'll just run this for however long it takes. That's just going to sit in the corner and we're never going to touch it. And if it works, then it works. And if it doesn't work, then it doesn't work, and we learned something. 256 days. I feel like it's almost impossible to like predict how many fish that is, so I'm not even going to try. I'm just going to move on and do the thing. Okay. The second part seems to be just an extension, right? So it's just doing more simulation basically. And I have kind of like 2 ideas for simulation, right? So we have the naive approach right now, right? But this isn't the actual, let's say, this isn't the optimal approach algorithmically. Let's go back. Let's commit this first. I'm going to commit the stuff that's here. And then we need to go in and we need to change the thing that we're doing here, right? So we're using puzzle input for both of these. Really the only change is whether we're doing 80 or 256. So I won't worry too much about it. Here, when we do this separated list, we are going to parse these in, and instead of doing like anything kind of, I guess, interesting, we're going to do a VecDeque. What is it called? VecDeque. I thought it was VecDeque, but maybe it's VecDeque. I don't actually know. But this is what we're going to use basically. So the solution, I think I don't know if it's optimal, but the solution in my head here is that we basically have all of these fish. And we can basically, instead of storing all of the fish and simulating all of the fish, we can store the amount of fish in any particular bucket and just move them from bucket to bucket. So here we have a vec of fish. We need to group this somehow. So maybe we do this. Maybe we do puzzle input, separated list, tag 0, whatever. And then do we have a VecDeque here? So let k equals, oh, they call it dec. We're not going to call it dec. We're going to call it k because I enjoy the WTF Spanish connotations. So VecDeque from, we don't want to do it from this though. I think we're just going to do a new one. And can we do a with capacity? Because we're only ever going to have 8. With capacity, or is it 9? I think it's 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I did just have to count on my hands for that. So VecDeque with capacity 9, which is going to give us type errors, I believe, because we need to specify that this is a VecDeque of something. Well, it can't be U8s, right? So let's do U32s. We'll just allow it to blow up if it blows up. I don't know how many fish we're going to have in each bucket. So we're going to have mute here, and we're going to fish.iter dot. Actually, can we collect into a vec? I guess we won't do that. We'll do iter, and we're just going to for num in fish.iter. This doesn't do entry API, does it? No, that's disappointing. We're going to do this. We're going to do get mute. Is this VecDeque initialized with 0 values is the question I have right now. Debug, okay. It feels like it would be, because I feel like VecDeque with capacity has to initialize something in the space, and that something would be 0 for a U32. So let's do this. I'm going to run that and do no capture. No capture. So we have empty. So let's do this instead. Let's do from, and we'll do 1, 2, 3, 4, 5, 6, 7. Actually, let's do the sneaky way. Let's do this. I think that works. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So then we have slot 0, 1, 2, 3, 4, 5, 6, 7, 8, which is what we need. So this is initialization for an array in Rust. And I basically just said, okay, well, if you're not going to initialize these with the default values from doing with capacity, because apparently with capacity just allocates memory but doesn't initialize it, we're going to initialize this array, and we're going to use a VecDeque with an array of zeros everywhere. And now that I think about it, we actually can do this the other way too, or is it garbage values like in C, C++? I think that if we did something like get on a VecDeque that wasn't initialized with values, we would get none instead of some, because you'll see that the type signature for VecDeque for like get mute is some element. So it's possible that there's nothing there. So we can initialize this with nothing there. I'm just debating whether I want to, because like we could do this too, right? Let mute r equals thing, and then this will be r later. And then we could do everything on an array here, which might be simpler for the moment, right? Like something like this. I don't even. Slice indices are of type usize or ranges of usize. Yeah, because a U8 can't fit into a usize. Thanks, Rust. I really hope that we get some additional traits and stuff. Did I not parse? I parsed down way down here. Well, to do this so that we can keep working. So the to do macro is really nice. It cuts off the type like completion. So we get to basically be like, yeah, sure, everything outside of this will have a VecDeque or a VecDeque of U8s. And in the meantime, we get to just be like, we didn't do that yet. Now this will be a runtime exception. Like it will be a panic if we actually do hit that piece of code. So you don't want to like leave to-dos in your application unless like you actually intend to go back and fill them in. Integer cannot be dereferenced. What am I doing here? Am I doing the wrong thing? Cannot infer type. Let's do this. If we're parsing, we can parse into usize. That feels weird, but we can. So we get the panic here as expected. This is the panic that you would see if you left the to-do macro just laying around. 0, 1, 2, 3. What are our tests? Where are our tests? Part 1, test. 1, 2, 3, 4. So 1, 2, 3, 3, 4. So this is working. And then the other one looks like it got over. Yeah, there's our 0 right there. We see a little bit of overlap because we panicked and it's dumping that out. But our 0 is like here in the output, and then 1, 2, 3, 3, 4. Perils of printing the standard out. So that works. So let's return the VecDeque here. This is not going to be a VecDeque of U8s anymore. It's going to be a VecDeque of U32s. This doesn't need to be mutable anymore. So now we've basically created an array from 0 to 9. We've filled that array with the number of fish that are at any particular point when we start. And then we do VecDeque from array just to create the VecDeque. Oh, that's sweet because I do empty values for return types while I code an implementation with the sole purpose of placating the compiler. Yes. So there's to do. There's also unimplemented, which you can use to be like, they're both panic at the end of the day, right? So there's the to do macro, and there's unimplemented, and there's panic. And they all do the same thing at the end of the day. The semantic differences are like a panic is a thing that happens, right? Like it can panic. And if it panics, you have to crash the program. That's when you use panic. When you use to do or unimplemented, you're kind of indicating missing functionality, not a panic in the program. So unimplemented means it's not implemented, and like we may not ever implement it. Like this may just be a path, a code path that we don't want to deal with. Who knows? It's just unimplemented. But to do gives the additional semantic meaning of, hey, well, you know, we're going to work on this at some point in the future. And we can stick a string in here to say like, because whatever, and give a reason. And that'll print out in the panic message. And it'll be like, to do, look at GitHub issue number 324 of the backlog that we'll never get to, you know, that kind of thing. Okay, so we get a queue. We don't need to do this extend from slice stuff anymore. We do need to iterate over the days. We get fishes. We're going to rotate it left by 1. I think that's the right thing to do. And then I think we take the number from 8 and we have to copy it to 6. So fishes.get 8 and fishes.get mute 6. I think 6. Old fishes plus equals new fishes. Our part 2 for the naive example still hasn't worked. We're going to unwrap both of these because they will always have a value. So I'm going to kind of explain what I just did here, right? There's a problem if we don't use clone here. That problem is we are getting a mutable reference to old fishes, right? Old fishes is just all the fish at 6. And we also have a shared reference from fishes.get, all the fishes at 8. And this is a mutable reference to the array and a shared reference to the array, right? So we can't have both of these. So what I'm doing is I am cloning the shared value just to copy it, right? It doesn't really matter. It's a U32. It's cheap for us, comparatively cheap anyway. And then we're going to use that value to add to new fishes. So we get to drop the shared reference. We get to take the mutable or exclusive reference, and then we can actually work with the exclusive reference. And that's what we see over here. Cannot borrow fishes as mutable because it's also borrowed as immutable. What if you swap those lines? We still need the exclusive reference to exist while the shared reference exists. So now we just see the error on the other one, right? We basically have an exclusive now and we're trying to take a shared, whereas before we had a shared and we're trying to take an exclusive. So no matter which order that comes out in, it does end up being the same semantic error. Let's see. Is get just a safer way to access indexes since you can handle when it doesn't exist? I don't actually know if you can access the indices on a VecDeque. Let's try it. I guess you can. So yeah, the only benefit of doing this then is to sort of recognize that there might not be a value there, or to get it as mutable, right? So we can do this, especially since we want to panic anyway if nothing exists, and we'll never have we will never not have a value there. I tend to like being explicit, especially when I'm doing index access. So like this makes me feel more comfortable. This, when I'm reading this code, makes me feel like, okay, this is an index access and it could potentially not be there for whatever reason. And we have to handle that somehow. And we're choosing to handle that with a panic because we expect it to be there, but we are still explicitly choosing to handle it. If I was doing more indexy stuff, I don't know, maybe I would change my mind, but Me writing it like this is kind of just a personal quirk more than it is required in this instance. So we're not doing fishes.length anymore. We're doing fishes.iter.sum. Sum is not implemented for usize. Why are we summing usizes? What do we get when we do a VecDeque iter? Let's get rid of the B tree map that we're not using up here. The trait sum reference to U32 is not implemented for usize. Makes sense. That's what I thought. Yeah. Oh, you know what? We're just going to make this a U32 because it happens to be. So our tests pass now. Let's see if we get the same number. Let's build with dhat. Reminder, our part 2 is still running. Method not found. What am I? Oh, because I'm building part 2 as well. I should have just put these in the same file. They're the same thing. This one is 256, right? But this also feels a little cleaner, right? Like this feels like the right thing to use, the data structure. Even though the other thing was like kind of like simple, it uses a couple for loops, it's fine, like it's all good. This still feels more understandable because we're using the data structure that lets us use like semantic functions, like we're rotating left and whatnot. Is there a reason you build and run instead of using cargo run? Okay, so there's 3 things, right? There's cargo check, there's cargo build, and there's cargo run. Usually what I do when I'm developing, Derek, is I do cargo watch, X check, X build, X test. And what that does is it runs check, because check is lightweight. And check will tell me if I have any like type issues or anything like that. And then if that works, then we can build. And doing a full build will do things that it'll execute like consts, right? Like it'll evaluate constants and replace them in the code and stuff like that. And then test will run the tests. And then like if I wanted to, I could also like X run here. I could do like a full pipeline, right? I could do this. Actually, one of them panics right now. That's what okay, I didn't specify it correctly. But basically, like I use cargo watch when I'm doing development off stream. And cargo build is just kind of a useful way for me to say, hey, we're building now when I'm talking in educational content and streaming. For this part specifically, we have to compile with release and the dhat feature, and then we have to run the binary. So that's why I do a cargo build release features dhat, and then I run it. Okay, so part 2 of the naive implementation is still running, and we have finished rewriting our code to use a better data structure and a better algorithm. And I know we didn't do criterion. Dang, I was going to do criterion on the first part. But I think it's obvious that maybe the first part isn't the best. So if we run cargo bin part 1, we still get 1820 and 8856, which is the same information. Let's copy these in. I'm just going to leave this running and see if it ever finishes until we're done with the stream. Super interesting, actually. Just to note that the difference between part 2 and part 1 didn't allocate anymore. We've basically locked the allocation into whatever number we want it to be. Let's do the part 1 heap. Heap, heap. Okay, so the part 1 heap ran in 600 nanoseconds, just to point that out, even with that. But we don't even allocate that much, so it's probably pretty close. We do 12 bytes for the file open, which is pretty consistent, actually. Every time we open a file, we deal with 12 bytes. This is the 64 bytes for the VecDeque, 600 bytes for reading the input in the actual file itself. Is it really only 600 bytes? Dang. 1,000 for once cell. Interesting. A sync once cell. Is that required for the... I didn't know they used once cell in, I guess, what is this? Locking standard out, basically. It is absolutely hilarious, though, that writing to standard out is big enough to show up in our heap allocation. And then this is the raw vec separated list 1. So if we can iterate over the string for the buff reader in nom more incrementally, then we can chop off, I don't know, 8,000 bytes on the Gmax and 16, probably cut that down total. Because we're basically constructing a giant vec, which we don't necessarily need to do. We just need to read it in and construct the VecDeque. So if we can directly construct the array that we build the VecDeque from, then we can get rid of all of this. Slightly off topic question, the default, do you call it with my type default or with the let thing my type equals default default? Personal preference. I typically use, let's see, in Bevy, I usually use default default. In SWC code that I write, I usually use default default because I move stuff around a bunch there. For educational purposes and some of my own stuff, sometimes I type my type default if I know what I want, and it's not going to change. Basically, what I do is if there's type inference available to rely on, I use default default. And if there isn't type inference available to rely on, if I'm constructing the thing, I just call the thing with the default values. That's what I do for defaults. But I don't have a strong preference one way or the other. I think default default is probably more confusing for beginners. So that's something to think about if you're writing any kind of technical content and you use default default. You will have to explain that there actually is type inference going on there, and it is calling the default function for the default trait implementation on the type that was inferred, basically. So anytime there's a lot more of that kind of thing going on, it creates a little bit more of a mental load for people. But doesn't really matter either way. Come on, initial part 2 code, you can do it. Nah, it's not going to happen. I'll let it run. I'll have the time it started because I will have started it on stream, but it's 11:11 right now. We started at 10. It's only been an hour. That's amazing. Let's stick this in the README. GAU commit. I'm going to call it there though. Thank you everyone for hanging out. I hope that, forget who came in earlier. I hope that the person who came in earlier who was looking for the part 2 solution got what they were looking for. And thanks everyone for hanging out. These are a lot of fun.